Hi there. Good morning, good afternoon, and good evening to wherever you are joining in from. Just before going live, I was thinking about how bad I was at math as a kid. And I just try to put my below average math skills to work. And if I put them correctly, we have been doing a webinar every 2 weeks. And it has been almost 2 months or more than an exact 2 months since we have been doing this webinar, which means that you have been joining us on these webinars for 2 months consistently. So thank you so much for joining in for all these webinars. I'm sure we will be doing a lot more in the future and providing you a lot more insights. With that, let me welcome you to the fourth installment of our platform engineering webinar. I am Atul. I work as a senior developer advocate at InfraCloud, where I take care of all the DevRel activities, which includes creating POCs and demos. I do a lot of writing around, blog posts and white papers and articles. I also deliver a lot of talks and do webinars like these. I am also a CNCF ambassador, so I organize meetups in my city, Hyderabad, here in India. And when I'm not doing either of those, I am a big time foodie and a travel blogger. So you can find me at a restaurant trying something new or driving my car to some new place. And like you might have already guessed, in today's webinar, we are going to talk about optimizing platform engineering workflows with Devtron. And I'm not here alone. I have a couple of guests on this webinar, and let me bring them on the front as well. So let me bring upon Abhinav and Vishal onto the stage. Hi, Abhinav. Hi, Vishal.
Hello, hi Atul, hi everyone.
Hey.
Hey, thanks for joining in. And Vishal is a familiar face here. Abhinav, for those of you who don't know, he's quite active in the community here in India and has been giving talks at a lot of places. So instead of me introducing him, Abhinav, why don't you tell our audience about you, who you are, what do you do, where are you based out of, and your interests outside of work?
Sure, Atul. Atul has already introduced me. This is Abhinav. I am working as a DevOps engineer at Devtron. When I'm not dealing with client issues, mostly I spend my time on writing blogs, reviewing blogs, or giving talks at different conferences. And apart from my work, I'm a full-time traveler, and I like to travel a lot of different places. Trekking is something which is very close to me. So I like to call myself as a Kubernetes head with a traveling soul.
Great. Thank you so much, Abhinav, for that wonderful introduction and for joining us today. Vishal, would you like to tell our audience about who you are and what you do?
Sure. Hi, I'm Vishal. I'm founder and CTO in InfraCloud Technologies. So I started my journey as a programmer way back, and then over time I shifted over to the systems and the cloud side. In the last, whatever number of years that I have been building InfraCloud, focus has been to help enterprise companies adopt open source technologies and be at the cutting edge of infrastructure technologies. I would say. Beyond work, you'll find me either in mountains or in books or watching, good made movies, basically. But yeah, that's briefly about me.
Great. Thank you so much, Abhinav and Vishal, for that quick introduction. So, for everyone who has been joining in for this webinar for the very first time, you can watch our previous webinars by scanning this QR code, and that will take you to our YouTube playlist where you can watch all the previous recordings. Having said that, it is not a requirement that you have a look at these webinars before starting this one. So in your leisure time, please feel free to go ahead and have a look at these webinars that we have done. So a couple of housekeeping stuffs before I actually dive into today's session. We would be taking in questions from all of you. So if you have any questions at any point in time, please put them in the comment box below, and I will be taking it up with our guest today. So talking about platform engineering as such. So this is a word that I'm sure a lot of you would have come across. And if I had to describe platform engineering, I often call it as the art and science of building something that I call as self-service portals that actually help developers focus on their core task and automate and abstract away a lot of things. Now, this entire definition might seem a bit a little complex. To simplify things, as a developer, when I am building something, necessarily writing the core logic for my application. There are a lot of other activities that I often do, probably setting up an environment, setting up the CI/CD pipeline, and things like these. Now, the whole idea about platform engineering was to offer these as a self-service portal. So, one of the things that we do is we create portals where we allow developers to request these services on their own, so that they focus on building what they have to, and all these abstractions are taken care of by the platform. To know more about the platform, what exactly a platform is, and probably more eh, to get a to get a better understanding of platforms, you can check out the CNCF platform white paper that was released a couple of months back. I think it's a very good starting point for anyone who wants to get into platform engineering. Now, based on our discussions at InfraCloud with our clients and with the community, we realized that a lot of people are aware of platform engineering, but only a few have an idea of where to start and what to do. So, based on our interactions with everyone, we realized that there are a few things that teams and organizations need to get started with their platform engineering journey. Things like blueprints, things like reference architecture. How do you actually get started? Things like tool suggestions, which are the right tools that you should have while building your platform, the capabilities that your platform should have, and also some questionnaires that help you understand where you are in your platform engineering journey. So we have combined all our learnings and experiences into this platform engineering reference architecture ebook, and this is available for free to download. So all you have to do is scan this QR code, and you can download this ebook and get started with your platform engineering journey. Now, as I said, there are a lot of things that are part of this ebook. One thing that I would like to highlight today is the platform engineering capability map. So what we essentially mean here is that every platform that you are trying to build needs to have certain capabilities that makes it complete. So when you are building a platform, you need to ensure that all the tasks or all the services that your developers require to build your application, to build their applications, are provided by these platforms. So if you see here, we have put them into 8 categories, and these categories are essentially under the develop bucket, which basically are the tools and services that developers use to build a particular application. So, things like workload specification, they need a spec to define their application, or things like, testing infrastructure, they need to have a testing infrastructure to test their application, or ephemeral environments, or pipelines, and things like that. So, our discussion point today will be around pipelines, and more deeply into understanding how pipelines help us build and optimize workflows on platform engineering for our developers. Now, shift left is one common term which I'm sure a lot of you would have heard. And, a small anecdote from my experience. When I joined the industry about a decade ago, I remember attending a meeting where I had my architects and managers discussing something. And I remember them mentioning shift left a lot of times. And I had absolutely no idea what shift left actually meant. So I just kept nodding my head in that group that, okay, hey, I know what you mean by shift left. But it was only after a couple of months that I realized what actually shifting left means and the benefit that it brings to the table. So, for a layman, shifting left basically means that doing certain activities as part of your software development lifecycle, or SDLC, earlier in the stage. So, for example, testing and finding bugs. You don't want to find bugs. You don't want your customers to find the bugs. Rather, you want them to, you want to find the bugs earlier in the stage and bring them closer to your developer or the development environment, because that's where you have more control. So over the years, we have been following the shift left strategy, and we have been pulling in a lot of things to the left. Now, while this has been very good in terms of resources, saving time and stuff, but there is a different angle to this where developers are interacting. So developers are taking it in a different way, and that is why this title shift left versus the developers. So Abhinav, why don't you tell us or shed some light on what do you think has been the experience of developers with respect to shifting left?
Sure. So you clearly mentioned about, right, what is shift left. So it's all about, it's an analogy where you shift things towards the left, right, towards the start of the SDLC. So if I give a small example here, right, let's say when you are building your CI/CD pipelines, so right where when you have committed your source code in the Git repository, thereafter you might want to perform static code analysis, right? And for that you might want to integrate some tool, for example, SonarQube, let's say. So when you are integrating these things in the pipeline, right, the configuration becomes difficult. The integration parts become difficult. There is one tool which has been introduced in your pipeline that needs to be managed now, which needs to be upgraded, installed, and all the management aspects. So it becomes difficult eventually when you are integrating multiple tools. This is just one of the example when you are integrating a static analysis. Let's say once the build process is done, again you want to have let's say container image scanning, right? Then you'll be integrating some other tool in the pipeline. For example, maybe it can be Trivy or it can be Clear or any of the security tools that you are using. Again, one more tool has been introduced. Now again, one more complexity has been introduced in the pipelines. You will have to install that tool, you will have to maintain that tool, upgrade that tool, all those configurations, right? And not just introducing tools, even if you talk about the configurations part, right? If we have integrated SonarQube, it's not just about the installation part, right? You will have to do different configurations for that, right? You will have to expose certain number of pods, certain number of pod, certain configurations. Maybe you are exposing it via ingress configurations. So everything becomes complex eventually. So as a developer, it's not my forte to understand all those Kubernetes configurations or understanding tools, right? My core objective is to write good code, really good code, not about understanding those kubectl commands or firing those different manifest files. So yeah, I think eventually things become difficult if I say if you integrate shift left practices and if you are not dealing with any such tool which can ease your process. Basically, if you are running on vanilla Kubernetes, then things might get difficult.
Interesting. I think you pointed out a really good thing that as a developer, my focus should be on writing code and not worrying about what the, firing kubectl commands or dealing with different tools. Vishal, coming to you, like Abhinav mentioned about how a developer is affected by the whole shift left ideology. Now, since you have been building teams for a large amount of time, for a long time, what is your thought on this from a larger perspective? How does it affect the overall productivity?
Sure, sure. So, if you look at the whole evolution of DevOps, basically, right? I think pre-DevOps world, everybody, was kind of coding, so to speak, from development side, and everything else, right, from operations to cost to security, was somebody else's headache, basically, right? And I think over time, what has happened is because of aligning of technologies, processes, and how you do, almost the cognitive overload of almost everything, right, from security to reliability to cost to how do you do for example, any configuration that you are doing in dev might affect performance in production is kind of shifted all over in a way, basically, right? And that means now developer has to also learn and think about some of these things, which were necessarily not their own specialty, so to speak, right? And that definitely has increased the cognitive load to an extent and has kind of led to platform engineering as a solution over time.
Interesting. I think you also reiterated the fact about the cognitive load. That is one thing that we have been discussing over the series that we have been doing, and how it actually affects the overall productivity. Now, while we saw the challenges that shifting left brings to the developers, platform engineering, as we have been discussing, is a way to shift right, if I can say so. Vishal, what are your thoughts on shifting right with platforms?
Right. So this is one of the most debatable opinion I have. As much as software engineering has shifted left, it has also shifted right. And what I mean by that, let me explain. Right. So we talk about, for example, progressive delivery, or A by B testing, and we are literally talking about taking your code to pre-prod or prod and doing, let's say 5% of traffic with this new version of the code base and see how it responds with real traffic, with real data, and with real users, for example. Right. So in my mind, that is a shift right of the software engineering from developers machine to real production environments. So as much as we talk about shift left of security and code and reliability and performance, there is also a fundamental shift right, because a lot of times you can't reproduce or can't get the same experience in a pre-prod or a staging environment either for lack of data or for lack of user traffic. And obviously, no matter how much you are trying to replicate or simulate, it is still not the real thing, right? Sometimes, the rubber needs to hit the road for you to get a real sense of, hey, my change is going to behave this way or that way. And those techniques, in my opinion, all the progressive delivery techniques are more of shifting right, closer to production, closer to users, closer to how things should work in real. And that obviously, we are talking about now shifting in both directions in a way. But to me, that's more interesting shift of shifting right, with platforms, and they should enable as much as shifting left, but also shifting right in terms of developers being able to experiment and do things in production without necessarily hurting the actual production environments or traffic or users, I would say.
Interesting. Rubber hitting the road. I think that is one takeaway from for me from this. You have articulated it really nicely that how important technologies and processes like progressive delivery help us reach closer to the production pre-prod environments and do things. Abhinav, how do you think platforms actually help us address the challenges that we discussed earlier from a developer's point of view?
Sure. So when we talk about developers, right? So it's all about developer productivity. So even if you are bringing any tool in the tool chain in the SDLC, introducing certain ethics or DevOps practices, it's all about increasing the productivity, right? It's all about reducing the market go time, right? So when platforms are being introduced, let's say if I talk about any internal developer platform that you are using, right? The very first thing is, as per me, the very first thing is that it reduces the tool chain complexities, right? Just like I talked about in the initial phase, when you are building a CI/CD pipeline, you'll be having multiple tools which needs to be integrated, right? Now you don't need to worry about the integration part. You don't need to worry about writing any of those manifests or deployment of those tools or maintenance of those tools. The platform should take care of all those complexities, right? Integrating with multiple different tools. And in fact, if we talk about DevOps as well, right, it has been one of the biggest challenges when you're working as a DevOps engineer. You're dealing with multiple tools, right? For observability, you have tons of other tools. Since you are also CNCF ambassador, I'm also CNCF ambassador. We are working closely with the CNCF landscape, right? If you see, there are multiple tools, tons of tools, right? How many tools you want to learn? So when you are integrating a platform, it reduces the entire complexity of integrating with multiple different tools, managing each tool individually. Let's say if I talk about security, it is already integrated within the tool. If I talk about observability, Grafana, let's say for example, or Prometheus for instance, it is already integrated within the tool. For CI/CD, it is already integrated with the tool. So you don't need to worry about any such complexities, right? In fact, when we talk about the upgrades part, let's say if it is specifically to Kubernetes, right? Let's say upgrade or management of the manifest or going ahead with the GitOps operations. So almost everything is managed within the tools itself. So you don't need to worry about any of the such underlying complexities. Second thing is it provides you intuitive dashboards, right? Having a clear dashboard wherein you can do everything from the UI, abstracting out all those complexities, right, which you have in the traditional Kubernetes. Again, Kubernetes is not a simple thing, right? Even if you spend a decade working on Kubernetes, you won't be able to say you are a Kubernetes expert, right? It's a complex tool. It will become more complex, right, in future. So having such abstraction layer, all that tooling system will really helpful for any of the developers, or even it will increase the develop productivity as well, right? You don't need to go ahead and do the same things again and again. So I think, yeah, platform will definitely help it.
Interesting take, Abhinav. I think the things you mentioned about the tool chain and the platform supporting integration of a lot of tools and eventually reducing the complexity. But one thing that I would like to pick from what you mentioned was you spoke about abstraction a lot, and I think the whole idea of having a platform is to abstract away a lot of, not a lot, but maybe a considerable amount of things from your developers, but also giving them the flexibility. So, for example, when I, as a new or junior developer, joins a team, uh, I should be able to perform a certain task with most abstraction. I mean, I don't want to be, getting into the details and configuring a lot of settings. All I want is, enter a repo, probably a URL, click a couple of buttons, and things are done. But the moment a senior dev is interacting with the platform, you want them to have more better control on the things that they want to do. So abstraction and flexibility, I think, are very critical when it comes to platform, and finding a right balance can be difficult. So How do you think that we can play with these two while we are building platforms, and are we taking away the freedom from them if we are just focusing on abstraction, or doing lesser of flexibility? Just your thoughts on abstraction versus flexibility in platforms.
So I think you mentioned it very rightly. So a perfect balance should be there between your abstraction layer and flexibility, right? So when we talk about the flexibility, so any of the open source tools that we use in the entire cloud native ecosystem, right? So what does flexibility means? So for example, currently you have a CI system which is already running, right? You are running perfectly fine with the CI system. Let's say you just want a tool which can be integrated with that existing tooling system, and you'll be able to deploy your applications, right? Be it a be it a GitOps approach, or let's say using the Helm-based deployments, right? And the next thing would be, let's say, not just about the integration of the tools, even if we talk about governance perspective, right? As a DevOps engineer, as a manager, I would not like to give access to everyone, every developer, every access, right? I should be having a proper control, proper guardian within. I should be able to give access to certain number of developers or DevOps engineer, or let's say, if a new joiners comes in, right? I should be able to give them restricted access to restricted environments, right? Maybe just view only access, wherein they won't be able to see any critical data, for example, right? So those kind of guardrails and those kind of guardrails will increase the flexibility of the platform. And if we talk about abstraction, right, very, very true, as you mentioned, right, you just click a couple of buttons and it should be done. So that kind of abstraction is really important. But again, if I want to debug certain things, right, if I'm facing certain issues, right, if I want to go deeper into the system, let's say if I want to check the logs, or maybe if I want to exec into the container, or let's say if I want to there is a concept of ephemeral containers in Kubernetes, right? So let's say with that particular concept, if I want to debug my container with some advanced troubleshooting tools, for example, Netshoot, right? So those kind of flexibility, or those even on the top of abstraction, right? Those kind of capabilities should be there within the platform, which will eventually increase the productivity as well, and it will help you to debug as well, right? If you want to go core into deep in the systems, you should be able to do it. So abstraction should be there, but on the top of abstraction, you should be able to see the core things as well. You should be able to debug, or you should be able to troubleshoot if there are any issues, or if you want to execute your, let's say, kubectl commands, right, for example, to, or let's say any of the utilities, if you want to integrate, maybe busybox or Netshoot or any of the tools that you want to integrate for the networking testing, right? So you should be able to do achieve those advanced capabilities as well. So that's my opinion of abstraction and the flexibility that a platform should be having.
Interesting takes. I think you did define clearly in terms of that even when I'm probably working with containers, I should have access to probably look inside the container and see what's actually happening. Vishal, I would again take this similar question to you as well. How do you think one maybe a platform team can find the right balance between abstraction and flexibility?
Uh, I think not just with platform, but generally with software, this is probably the hardest problem of all to solve. Even every company will have a different level and need of abstraction versus how much flexibility they want. Even within the same company, over time, this level of what is abstraction, what is flexibility they want would kind of differ basically. So if I give an example, Terraform is a great language for provisioning cloud resources, and I can say, hey, what, go and use all the modules onto public whatever EKS, GKE kind of modules, right? But then some teams would say, hey, what, I really want to write a smaller layer on top of Terraform and only give 4 knobs for provisioning a database that my team can change, for example, right? This is a great thing to start if you're new to Terraform, if you're new to infrastructure as a code, basically. But once team have matured, they might say, hey, what, these 4 knobs are not enough for me. I want more knobs to be turned as per my requirement. So suddenly, what was good as an abstraction for the team at the beginning of the journey is becoming rigid and inflexible, at some point in time. So I think the context of the org and the context of the problem you're trying to solve is the most critical thing. And the complicated part here is that context will change. The org that was at a state a year before today and a year later from today is going to be different. So to constantly kind of hit a moving target. And that's the problem in my opinion with abstraction versus flexibility. And that's why getting the products right, as a platform is probably a little more trickier than otherwise, I would say.
Interesting. I think we can probably do a dedicated session entirely on context and how the whole abstraction and the flexibility debate changes right when the organization is just
Absolutely.
starting out, and how it actually matures over time. So I think we have had a good discussion until now. We started with the shifting left and how it affects the developers, and then seeing how we can shift right, get closer to the pre-prod environments, or as Vishal said, burn the rubber on the road. And lastly, we touched upon the abstraction versus flexibility debate. So while we had all these interactions and discussions along these lines, we do look at some of the tools and platforms that actually help us solve this particular problem. And one of the tools that I had actually experienced some time back was Devtron. So I had actually experienced this in 2021, if I am not wrong. And from then till now, Devtron has changed quite a bit. And I think Abhinav is the right person to help us understand what all are the enhancements that have come to the platform and how it helps us optimize workflows for developers. So Abhinav, the stage is all yours now.
Thank you so much. So, giving so small introduction about Devtron. So, for those who are not aware of Devtron, it's a open source Kubernetes native software delivery platform specifically designed for Kubernetes. So, with this single pane of glass, you should be able to create your CI/CD pipelines, which are Kubernetes native CI/CD pipelines. You would be able to do all your GitOps operations. So, we say when you are using Devtron, you are day one GitOps enabled, and you should be able to control your pipelines that you mentioned about, right? You should be able to create policy driven pipelines. The user access management part, which is again one of the most critical things and one of the most complex piece when we talk about Kubernetes, it can be easily managed with Devtron. The observability aspect, the monitoring aspect, the troubleshooting, or let's say security or governance at different stages of your pipeline, almost each and everything that you want to do in Kubernetes, right? Everything in Kubernetes from A to Z. So it should be controlled easily with the single pane of glass. Now, when we talk about platform engineers, right? So we have been talking a lot about platform engineers, the challenges developers face, shifting right versus shifting left, flexibility, everything, right? So as a platform engineer, there are multiple challenges that they has to go through, right? So the very first thing that we initially talked about is a nightmare of managing multiple different tool chains. So as a DevOps engineer as well, if you see, right, you are dealing with multiple different tools simultaneously. So tackling all those tools, making sure the upgrades are hassle free, making sure the maintenance of those tools are hassle free, it becomes really difficult when more number of tools are being introduced in the system. Availability and fault tolerance again is one of the most important things. So when we talk about IDPs, right, internal developer platforms, which is essentially a part of platform engineers to manage the entire IDP of a system, of an organization, right? So we obviously have two ways. So either we can build the entire IDP within in-house, or we can buy or use some open source tools for that, right? So making sure it's available and its availability all the time, it's again one of the biggest challenge that a platform engineer has to go through. Again, continuous integration and continuous delivery is again one of the big problem statement that we are talking about. So currently in the traditional way, we have some different CI tool systems, right, which are working for CI. We have different tools which are working specifically for the CD operations, right? Again, for integrating those things, we are writing different custom scripts. We are writing our own bash scripts or Python scripts so that we make sure everything is automated end to end. But what's the need of writing those custom scripts, right? Eventually you will have to improve those scripts or again add one more script to back up your previous script, right? So having a platform which does everything with seamless without any such custom scripting is again a plus point. And managing those CI/CD individually is again one of the biggest pain point of any of the engineers that are dealing with this, right? Compatibility with evolving technologies. If we talk about Kubernetes, just Kubernetes, not other tooling system. So almost every 2 months we get a new upgrade in Kubernetes, right? And with every upgrade in Kubernetes, we get a lot of different things. Maybe some of the API versions are deprecated. Some of the Kubernetes configuration in the manifest are itself changed. Again, managing those things individually becomes a nightmare for any of the engineers. Upgrading Kubernetes cluster itself is a big nightmare of any of the engineer, right? Thereafter, troubleshooting and debugging, again, it's one very important if you're dealing with platforms. So when you're talking about a self-serve model, right, when you're empowering your developers, you should make sure that developers are able to check, right, they are able to at least debug their application on the pre-prod or let's say staging environments, not if in prod environments, right? So at least those flexibility should be there in the platform. Thereafter, cost optimization is something that everyone is running behind, right, today. Everyone is running for cost optimization, be it your infra cost optimization or for your workload that you're deploying onto the Kubernetes environment. So having such features natively integrated within the system, or let's say bulk operations, which will help you to achieve those things. For example, hibernation of the workloads, right? Or sleep of the or deletion of the workloads. So these are something which again it's a big nightmare for any of the platform engineer when they are building their own tooling systems, or if they're leveraging or maintaining it manually, right? Then again, as we talked about in the initial slides, ephemeral environments. So if you want to test out certain things, right, quickly have my environment set up, test out things. If everything, every unit test case, everything passes away, delete the particular environment, right? So ephemeral environments, having ephemeral containers, everything in place is again one of the biggest pain point of platform engineers. And yeah, as we talked about, a self-serve model for different teams, right? When you're dealing with a big organization, you have multiple different teams, right? You must have to deal with multi-tenancy at that point of time, right? So the different teams can work on their different projects, and everything is isolated from each other, right? So providing such or building such self-serve model is again one of the most difficult thing here. So these are a couple of dilemmas of a platform engineer. Now it's time for some hands-on. So let me quickly share my screen. Perfect. So this is a preview environment which everyone can access here. Let me go ahead and log out the environment. So you should be able to access with your, you can directly log in with your GitHub. And when I say Devtron, right, Devtron is again one more thing I want to highlight here. So it's 100% cloud and cluster agnostic. So be it as small as K3s or micro KTS clusters, or as big as managed clusters, for example, AWS EKS, or let's say AKS, Azure AKS. So you should be able to install Devtron and manage it from everywhere, right? And any of the integrations that we talked about, right? If I go ahead here, like, so if I come to the authorization part, so currently we have integrated GitHub for the SSO, but if you want to integrate with any of the other SSO login services providers, maybe Google or Microsoft or LDAP or GitHub or Keycloak, any of the things that you're using, you should be easily able to integrate with those SSO login providers, and you can easily manage the user permission. For example, let's say if I have to give a permission to Atul, let's say Atul at the rate Devtron.ai, for instance. So if I want to add a new user, right? So this is my new user. I can either give a permission groups, and permission groups are nothing but a way of giving different permissions to a specific user group of interest, right? For example, for my new joiners or interns, I can give a permission for just view only access. Or let's say for my DevOps and infra admin, for the respective environments in which they are working, I can give the entire access to them, right? Or maybe engineering managers, I can give them manager access, or certain ways, right? So either I can use permission groups, or I can give specific specific applications for specific projects. For example, for this user, let's go with a demo project. I can see all my environments which are there in this particular demo project. Let's say if I want to give Atul access to these three environments, I can see all my applications which are being deployed in these three environments. I can select each application here. Let's say I want to give the access to these two applications, and when I come to role here, so there are multiple different roles here. So first is manager role. So manager role is something like a super admin role for this particular user, for this particular project, and the environment in which this particular user has the access to. They would be able to do almost everything, be it making any kind of configuration changes or user access management part. Admin is someone who would be able to make configuration changes, but they won't be able to play around anything in the user access management part. Build and deploy is something a user would be able to just build and deploy their applications in the respective environment in which they have the access to, but they won't be able to make any kind of configuration changes. View only is something they would be able to see the entire pipelines, everything, but they won't be able to make any kind of configuration changes, and they won't even be able to see any of the critical values. Now again, there is something called image approver and configuration approver at Devtron. So these are part of enterprise feature that we have as of today. So as an image approver, right, you can control which user has the permission to approve certain images. When we are talking about advanced pipelines, right? So in a traditional production pipeline, we would be having some approval checks as well, right? Wherein once the images are being approved, then only it can be deployed to certain environments. So the user who can approve those images can be controlled through RBAC at Devtron. And thereafter, if you want to protect configurations of certain environment, for example, your production environment, right? In your production environment, you want no one should be able to make any changes and directly deploy it to the respective environment. It should be first reviewed and approved before it get deployed. So you can control that as well from user access management part. You can specify which user is a configuration approver from RBAC itself. So it's just about your Kubernetes applications. And when I say Devtron applications, it's your microservices which you connect, which we will walk through later in the demo. There are Helm charts as well, so you would be able to give certain permissions to Helm charts as well, the same way you would be able to give for your different applications. And not only for the Helm chart that you have deployed with Devtron, but also if you have used or deployed any Helm chart using Helm CLI, you'd be able to control the RBAC part of that Helm chart from the different UI itself. And one of the interesting things that I want to show here, so if I go to the resource browser, right, so you should be able to control the permissions even for a specific resource. And when I say resource, let me quickly show you. So I can select my cluster. I can go ahead, select my namespace, let's say Devtron CD. I can select the API group for which I want to give the access to. Let's go with the core components. I can select a specific kind here as well. Let's say I want to give just access to a config map. I can select my config map. I can select my resources here. I can have multiple resources for which I want to give the access to, or individual resource, and I can give the access as a admin or view only access for this particular user. So this level of fine-grained access management is possible with Devtron, which can help you achieve your multi-tenancy, can create a governance or control over the users' permissions part, basically for any of the users. So this is about the access management and Devtron. Now let me come over to the applications. So when we see these applications, right, these applications are collection of different resources which are being deployed for a Kubernetes environment. For example, you have a one microservice, right? When you deploy one microservice, along with that one microservice, multiple different Kubernetes objects are being deployed, right? If I quickly show you here, let's say production environment. So along with one microservice, multiple different Kubernetes objects are being deployed here. So an application at Devtron is a collection of all those resources, which you can see in a resource group manner for all the resources which are being deployed with this particular application. And along with the resources, it's a collection of all different environments in which this particular application is being deployed. So let's go to the configurations now. So for example, whenever you want to create any application, you will directly come to the application configurations, wherein you have certain number of configuration needs to be done, and you don't need to worry about any of the underlying complexities. Just provide the repo URL, click on next, go to the build configuration. Build configuration is where you would be specifying where you want to store your container images and how you want to build your container images. And again, for storing your container images, you can simply use any of the container registries. These container registries again are governed from the global configuration only. So from global configuration, you should be able to specify which container registry you want to use, and how do you want to build your container image. So traditionally, if you are already into Kubernetes, you must be having a Docker file for that. You can directly use the Docker file. You can provide a build context from where you want to execute the build. Or let's say if you are in a phase of migration, right, if you want to migrate into the container ecosystem, so there are predefined Docker file templates given for different languages and frameworks. You should be able to leverage these different Docker files for creating your container images. Or again, there's one of the interesting tool of that is there in Cloud Native CNCF ecosystem, which is Cloud Native build packs. So Cloud Native build packs is again integrated within the pipelines. You simply need to give your language, just provide the language, the version which it is being used, and you're done with everything. You don't need to worry about any of the Docker file or any of the build mechanisms. It will automatically build a container image for you and push it to the repository which you have given the access to. Now, again, if we talk about some advanced configuration, right, when you're dealing with multi-architecture nodes or multi-architecture nodes, right? So you must be willing to create multi-architecture containers as well, right? So you don't need to worry about executing commands individually. Simply, you can just select those different architectures for which you want to build the container images, and you are done with the configurations. So it will automatically build a multi-architecture image for you. The next is deployment template. So we were talking about the configuration part, right? Configuration becomes really difficult for any of the developers then when they are using. And even if we talk about Kubernetes upgrades, right? It becomes really difficult if certain API versions are being deprecated, or let's say configurations are being changed. So for managing all those things, it becomes really, really difficult. So with this deployment template, which you see here, right, you would be able to do almost each and everything that you want to do. For instance, let's say I want to create an ingress object. I can simply click on ingress. I can see my ingress object. I just need to enable it, provide the class name, provide the host, and I'm done with the configurations. I don't need to worry about any of the complexities of writing the entire manifest file or upgrading those manifest file. If I give a small example here, right, in Kubernetes version 1.21, if I'm not wrong, in 1.21, the API version of Ingress was deprecated. So earlier it was extensions.kubernetes.io. but it was new API version was being introduced, which was networking.ktos.io, which is I think currently being used, right? So when this major change came in, so for almost any of the users, almost everyone using Kubernetes might be using Ingress, I assume, right? So whenever you're dealing with Ingress, you in such changes when you want to upgrade your Kubernetes cluster, you would be changing the entire manifest file for those Kubernetes ingresses which you have created. You will change the entire API version for every ingress object that you have created, and it's become a lot of hassle, right? With these particular systems, you don't need to worry about any such complexities. You just need to make sure you are using the latest version of the chart and nothing. Internally, Devtron will take care of all the backward compatibility and the forward compatibility with the latest Kubernetes releases, and all the manifest and everything will automatically created. Even if I talk about advanced autoscalers, right? Let's say KEDA. KEDA is an advanced event-driven autoscaler, right? So simply enable the KEDA object, provide the triggers, and you're done with the configurations. You don't need to worry about creating the scaled object or HPAs, any of the things. Or even if you are going ahead with the simple auto scaling, right? HPA. Simply enable the HPA, provide the minimum replicas, target CPU utilization, target memory utilization, and you're done. And when we talk about developer productivity or self-serve models, right? So again, it's not a for a developer to understand these parameters, right? As we initially discussed. So here it comes with a README, right? You can see all those parameters here itself, and depending upon the parameters, you would be getting the examples as well, how to uh, configure those parameters. So you can check out those parameters here in the README, and thereafter you can configure it directly. And in fact, you don't need to worry about any misconfigurations here because it goes through a basic linting. For example, grace period should be given in integer, right? But let's say if I give a string value, it will clearly give me an error that string doesn't matches the pattern, right? It should be an integer. So a basic linting is already there within this deployment template. So in this way, you'd be able to make any kind of configuration changes, any kind of Kubernetes configuration that you want to give for your application with this base deployment template. Now, coming to the pipeline, so here Devtron, we call it as a workflow editor, wherein you can create multiple different workflows for multiple different pipelines. The first pipeline that you see here, right, it's a sequential pipeline, wherein once you build your image, it will be promoted to the staging environment. Thereafter, at certain checks, if there are any, it will be promoted to the production environment. Or let's say if you want to build a parallel pipeline, right, once you build your container image, simply it should be deployed to all different multiple environments, right? Or any kind of mixed match is possible with different pipelines that you want to deal with. And when we go deeper into the pipelines, right, we talked about the mandatory pipelines or policy driven pipelines, right? Or different integrating different tool chains within the pipeline. So if I click the build pipeline, I can see my different plugins which are already there in place. Let's say I want to integrate Sonar Cube, right? I can simply go to the Sonar Cube, I can go to the input variables, and I can provide my project API, endpoint API, and endpoint API, the path, API keys, and project keys, and I'm done with the configurations. I don't need to worry about entire manual configurations or writing custom script for automating all those tasks. You are done with the integration, right? You don't need to worry about any of the underlying complexities. And it is true for any of the Sonar Cube that you're using. Let's say if you're using Sonar Cloud, right? You can simply get the project key, API key, endpoints directly from Sonar Cloud as well, and you can provide it here for your applications. So next time when this build will be triggered, automatically a entire analysis of your Sonar Cube analysis will be sent to your Sonar dashboard. And in fact, if you want to install or manage self-hosted Sonar Cube, you can do it via Helm charts directly in your Helm Kubernetes cluster as well, right? So this is something which I want to highlight here. It can be any of the tools that you want to use. Let's say if you want to close a Jira ticket once the build is been done, right? Or let's say update a Jira ticket once with the image IDs so that this particular image has been built, or any of the things that you want to do in the CI/CD pipelines can be easily achieved here, and you don't need to worry about any of the custom scripting thing. In certain cases, you will need to write custom script, right? So there is an option to write execute custom script as well. You can go ahead and you can execute your entire cell script, or if you already have a container images built with all the utilities, all the scripts, you can simply provide that image here and you can execute your pre-build or post-build stages. Now, again, if you see here, right, let me quickly show you the mandatory plugin as well. So if you see here, there's an action required button here, right? So mandatory plugin is being configured for this particular pipeline. And if I click on the plugin, I can see a SonarQube plugin, which states it should be there in my production environment. Now, again, at Devtron, you'll be able to govern those, create those kind of policies to enforce certain plugins or tags while creating in your entire CI/CD pipeline. So you can create it from the global configurations. So I think we don't have much time here, so I won't be going through each and every configurations. So you'll be able to do it to the global configuration. You can create certain number of policies there, and you'd be able to enforce certain policies within your pipelines. And same thing goes for your post deployment stage as well. And again, in the pipeline itself, right, you can clearly see vulnerability scanning image toggle button. You don't need to worry about any of the underlying complexity, not of the installing of the tool, maintaining of the tool, executing the commands for scanning of those container images. Simply toggle on this button, and you're done with everything. And on the top of the results that you'd be getting, right, which I will show you here. So on the top of the results which you'd be getting after the container image has been scanned, you'd be able to create multiple different policies as well, right? So once you're done with the build pipeline, you can simply come to the build and deploy section, wherein you can select the latest commit, or any of the commit for which you want to build the container image. And once you are done with building the container image, you'll be able to see all the logs, and it uses the centralized caching mechanism so that the builds are faster when you are building the next time, right? You can check the source, you can check the artifacts, you can check the security scans, and depending upon these scans, if I quickly go to my deployment environment and try to select the container image, right, I can see since in this image vulnerabilities were found, so it won't be able to deploy in this particular environment. So I can define certain these type of security policies as well, depending upon the vulnerabilities which are found. And in fact, if I go ahead and try to deploy this application, right, I can check my config diff as well, the configuration diff basically, be it of your deployment pipeline or of your pipeline configuration, any of the things which you have changed, so that you know you are deploying right things, right? And again, if I go back to the application configurations, so as soon as you create multiple different deployment pipelines, you'd be able to see multiple different environment overrides as well. And for each of your deployment pipeline, which is basically your deployment environment, right? You can specify for which environment you want to deploy, production environment, how do you want to execute, manual or automatic, and if you want to go with the GitOps base of deployment or Helm base of deployment. And for each pipeline, also each deployment pipeline, you'll be able to select your deployment strategy as well. Let's say if you want to go ahead with the rolling, blue, green, canary, recreate, you can do it depending upon your requirement. And you can even select for approval based deployment if you want to, right? And once you're done with this pipeline creation, you'd be able to see this environment overrides, and under environment overrides, you'd be able to see these different configurations as well for each specific environment. And if I go ahead here, right, let's say for my production environment, all my configuration here in my production environment would be different than what I do in my playground environment. So everything you should be able to control here with this single pane of dashboard. You don't need to worry about any of the underlying complexities. You can clearly check a diff between your multiple different environment configurations. If I see my production configurations against my staging configuration, right, I can see the entire diff between those two configurations, those two environment configurations. So almost everything that you want to do here, and almost everything is perfectly feasible. And even if I talk about the flexibilities or those kind of things, if you want to have certain custom let's say custom manifest, you want to deploy custom manifest, right? So we have something called raw YAML. In the raw YAML, you can provide the entire object itself, the entire manifest object which you want to deploy, basically, if you want to deploy anything. So almost all the complexities and everything is being reduced, and you get the entire flexibility with such systems. And for deployment as well, once you deploy your application, right, so once you deploy your application, you can directly come to the application details, wherein you'll be able to see the entire details of your applications, be it the application metrics, CPU users, memory users, throughput, or let's say the entire workloads which are being deployed, the entire Kubernetes resources which are being deployed here, along with if I see the deployment object, right, I can see the manifest, I can see the event, or in fact, if I want to check cluster-wide applications, right, I can simply go to my resource browser. In resource browser, I can select my cluster, I can select my workloads, and I can see all the objects throughout my cluster. So that particular view was specific to application view. And if I go ahead with the entire cluster view, I can do it here with the resource browser itself. And in fact, if I want to have some bulk operations, right, let's say for a particular environment, I want to deploy all or build all my applications, right? So with this particular application groups at Devtron, you should be able to perform certain bulk operations for your respective environments. So you would be able to see all the applications which are being deployed in this particular environment, and thereafter you would be able to select all the applications and trigger a bulk build, or directly deploy the application directly into the respective environments. Or in fact, if I want to hibernate all the applications, right, in this, let's say if it is my testing environment and I want to hibernate all the or scale down all the workloads, I can simply select all the application and I can hibernate it. Or in fact, if I want to make changes directly to the application or compare those changes, I should be able to achieve almost everything with this application groups that you can see here. So it's a small gist about Devtron. It's a very small gist about Devtron. Since we don't have much time, so I won't extend the demo. But if you want to understand in details, you can go ahead and you can sign up in the different website itself, and we should be able to help you with that. Or you can simply join our Discord channel, and we should be able to give entire demo for that as well. So it's a small introduction about Devtron, and here you can see in the screen, right? These are a couple of resources that you can use. So you can get the videos, small snippets of the videos at different website. You can check the well-maintained documentation with all the feature upgrades, all the feature updated. You can check the ebooks on developer productivity and couple of more which are already there in the website. You can check our YouTube channel where we try to push different features and all those things. Thereafter, blogs. You can check the latest blogs and how to's with Devtron, certain use cases with Devtron, how it can be achieved. We try to do every month webinar. You can see those in the website itself, and you can scan this QR code, wherein you should be able to see. You will be led to the GitHub page, and you can start it if you like it, and you can check out all the resources and try it hands-on if you want to. So that's a small introduction about Devtron.
Wow, I don't know how many of you noticed me smiling multiple times during the demo. And the very reason I was smiling was that looking at a lot of features that Abhinav showed in Devtron, I was like, okay, this is something that I break my head a lot to configure. When he showed about application configurations or the entire Helm chart upgradation, I think it was very easy that that Devtron does it. So I think, yeah, thanks Abhinav for the wonderful and insightful demo. I'm sure that apart from these items that you have listed here, videos, documents, ebook, YouTube, blogs, and webinars. Even this webinar was quite insightful. Even though Abhinav says there was less time, I think he covered the entire gamut of Devtron offerings quite well in this. So yeah, I think we are at top of the time. But before I end, I'm just going through the comments, and I have a couple of comments here. And Abhinav, there is one interesting question that is there from Janvi. I'm just putting it up on the screen. I think this is a question related to configuring registries with Devtron. So she asks, can I configure a private registry with Devtron?
Yes, easily you should be able to do it. And in fact, all the enterprises are using private registry only, right? They won't use the public registries. So you should be able to use or configure your private registries with Devtron from the global configurations. And in fact, not just the private registries which are being provided by different cloud providers. Even if you're using certain, let's say, Harbor, which is a self-hosted container registry, right? Even if you're using those kind of things, it can also be configured with Devtron. That's not an issue at all.
Interesting. I hope, Janvi, this answers your question. If you have a registry on-prem, it can be configured on Devtron as well. So yeah, quickly, summing things up, I think we did have a good discussion for close to an hour now. I think one of the longest that we have done in the past few webinars. But I think we discussed a lot of things, right from talking about how shifting left affects the developers' productivity, and then how we are trying to shift right with a lot of things and platforms like progressive delivery, reaching closer to the prod environment, and eventually identifying and understanding how to find the right balance between abstraction and flexibility. And the answer to that was the context changes as the organization or the team evolves over time. And lastly, to sum up all our discussion, I think the demo by Abhinav was the icing on the cake. We looked at all the gamut of things that we discussed, right from abstraction, flexibility, and everything related to that. So once again, thank you so much, Abhinav and Vishal, for joining in for this webinar, and to all of you as well. Thank you so much for joining in and tuning in. You can download the platform architecture ebook by scanning this QR code, and we would be doing similar webinars in the future as well. So you can keep following us on LinkedIn and Twitter for future updates. So with that, we all are signing off for the day and looking forward to seeing all of you in our upcoming webinar as well. So thank you so much and have a wonderful time ahead.
Thanks, Azul. Bye bye.